Okay, today we are going to start another module which is cams. So we are going to see how the cams will move and more information about the cams. So in this module is basically we look into the introduction and types, and after once we finish these two things, we'll try to solve some numericals, or basically we graphically try to draw the cam profile so that the follower will act or move accordingly. So for that matter, we need to draw a cam profile, and we'll see how we can draw the cam profile in the through the use of different graphical solutions. Okay, so what is cam? So there are basically before we go into the detail of cam, we look at the cam is basically a combination of two things: cam and follower, and they are basically associated with each other to perform a specific motion, a constrained motion, a kind of a motion that we need to have as output. Both cam and followers are attached with the frame so that they can move properly. The velocity of the frame is zero, so frame is stationary, or we can say it's kind of a rigid body. So we will not look at the frame as much as possible. We will not look at the frame. In fact, we are not going to discuss the frame at all. We are only going to look how the cam will move and how the follower will follow the cam. So our target in this module is only, we will look mostly the cam and follower to see how we can execute the required motion, the constrained motion which we have. So what is a cam? A cam is a mechanical member used to impart design motion to a follower by direct contact. So in a cam, there is a mechanical contact between the cam and the follower. The cam will move, and because of the motion of the cam, the follower will follow it. The profile of the cam will dictate in which direction or in which way the follower should move. So there is a mechanical contact between the cam and the follower. Cam itself is, as we said, that there are two parts, cam and the follower. The cam itself can be rotating, so it can be rotate, reciprocating, whereas the follower may be rotating, reciprocating, and oscillating. So it can oscillate between 2 points, maybe in a straight line or non-straight line. It depends upon the whole construction or the way they are in contact. The cam and follower are in contact with each other. Cam are very important because if we want to have a kind of a motion like two circular motions, then we have mechanisms like you can say pulley or gears. They can allow the both shafts, the driver shaft and driven shaft, to move in a circular or rotary manner. But if you want to have a intermittent, or we want to have a motion which is going to be within a one rotation, it's going to be stop, stay, up and down, oscillating, rotating, reciprocating, then we need to have a cam. So the complicated output motion which are otherwise difficult, or in my words, I think some of the cases it's impossible to achieve, can easily be produced through the help of the design of the cam and the followers. These complicated motions may be very challenging if we try to do some other mechanism. Cams are widely used in automatic machines, internal combustion engines, machine tools, printing control mechanisms, and etc. So there are plenty of examples where we can see the cams are or can be employed. So this is one of the good example where you can see the cam is there. So this part, this yellow part, is basically the follower. So you can see it is following. This is the shaft. This is the axis of the shaft which is rotating. So you can see the cam itself is not a circular in shape. It is a different kind of a shape. So every time this is going to be in a larger part, larger diameter, it will push this down. This follower will down. and some part of the cam where the diameter is like constant. So you can see this follower, this yellow color follower, stays at its position, and it's wait until during the rotation the larger part will come and push it down. During the whole time you can see the cam and the follower both are in contact, and there is a mechanical contact in between them. So you can see over here, this is, once again I'll just quickly repeat it, axis of the shaft. This part is cam, this part is follower. When the cam is rotating, depending upon the profile of the cam, this follower will go up and down, and the way it is going to look into the to perform a specific motion. So this mechanism is used in internal combustion engine. So you can see over here the camshaft, the cross section of the camshaft, and these are the two walls. So you can see at a specific cycle of this 4-stroke engine, for each cycle the cam is performing its duty to open and close the valve. So this mechanism, which you can see on your left hand side, and this mechanism is exactly the same for the internal combustion engine. So you can see when the fresh air is required, this valve open, the fuel inject, there is a combustion, then this exhaust valve open, exhaust gone, and the cycle will repeat itself. So this is the first cycle, second cycle, third cycle, fourth cycle. And only the cam can perform very precisely when to open the valve and when not to open the valve and keep it a closed volume.